Welcome to Fixing Your Factory Flaws, and welcome back all you subscribers. I want to start this video with a question. How many parts have been scrapped in your shop? Not because the machine was wrong, not because the tooling was bad, not because the operator made a mistake, but because two people were reading the same print differently. Think about that. An operator says the part is good. The inspector says it's bad. Engineering gets involved. Production stops. Meetings start. Finger pointing begins. Meanwhile, the customer still expects parts. Now, let me ask you another question. How many times has production stopped because a 10-cent component wasn't available? Or because one material shipment was late? Or because one machine that should have been replaced 10 years ago finally decided it was done? These are conversations nobody wants to have, because the biggest problem in manufacturing are often invisible. They're not dramatic. They're not exciting. They're hidden. And hidden problems usually are the most expensive. Let's talk about one of the oldest battles in manufacturing. Operators versus inspectors. And before anyone gets upset, this is an attack on either group, because both sides are usually trying to do the same thing: make good parts. The problem begins when communication breaks down. The operator measures a part one way, the inspector measures it another way. Now they're getting two different results. The operator becomes frustrated. Management becomes frustrated. And nobody asks the real question: are we measuring the same feature the same way? Because you'd be shocked how often the answer is no. I've seen shops where three different inspectors measure the same feature three different ways. I've seen quality departments relying on tribal knowledge instead of documented methods. And then everybody wanders around or wonders why they're confused. The answer is simple. The process itself is broken. Now, let's get controversial. A lot of people pretend to understand geometric dimensioning and tolerances, or GD&T. They don't. And that's okay, because GD&T can be intimidating. The symbols, the datums, the feature control frames, profile tolerances, the positional tolerances, the true position calculations. Many operators see a complicated print and immediately feel overwhelmed. Some supervisors do too. Heck, some managers do too. And occasionally, even engineers. The problem isn't that people don't know everything. The problem is pretending they do. Good shops invest in training. They explain why datums matter. They explain how features relate to each other. They teach the reasoning behind the print. Because when employees understand the why, the print becomes less intimidating. And when GD&T becomes easier to understand, quality improves dramatically. Here's another uncomfortable truth. Just because a measurement came from a surface plate doesn't automatically mean it's correct. I've watched people spend thousands of dollars on measurement equipment, then use poor setups, poor fixturing, poor alignment, poor reference points, and somehow assume the number must be correct because the equipment is expensive. Measurement is a process, not an event. If the setup is wrong, the result is wrong. If the datum simulation is wrong, the result is wrong. If the part isn't seated correctly, the result is wrong. And if people don't understand what they're measuring, Guess what? The result is wrong. The best quality department don't just buy equipment, they train people because the equipment isn't making the decision, people are. Okay, now let's shift gears because quality isn't the only invisible problem. Let's talk about downtime, not machine breakdown time, the hidden downtime, the kind nobody tracks, the operator waiting for material, the forklift searching for pallets, the supervisor looking for paperwork, the maintenance technician hunting for parts, the setup person waiting for tooling, the production scheduler making last minute changes. All these seem small until you add them together. Then suddenly, you're losing hundreds of hours every year and nobody notices because the downtime never gets recorded. One of the biggest profit killers I see is manual changeovers. A machine isn't making money during changeovers, it's waiting. Now imagine a shop performs 20 changeovers per day, every day, all year long. How much production is being lost? The best operations attack changeover time relentlessly. The stage tools, they stage material, they standardize procedures, they organize workspaces, they eliminate wasted motion. And in the Kaizen, that's Muda, which is waste. Because every minute saved during changeovers creates capacity. Capacity creates profit. And profit creates possible raises or bonuses. Let's talk about that machine that everybody is afraid to replace. Every shop has one. The old machine. The machine held together with hopes and dreams. The machine that only one person in the shop knows how to fix. The machine nobody wants to touch. And management keeps saying, we'll replace that next year. Till the next year comes and it's still there. Then one day it breaks and suddenly production stops. Orders stop. Revenue stop. Customers get angry. Emergency repairs begin. The truth, the machine was waiting or warning you for years. Most catastrophic failures aren't surprises. They're ignored warnings. Here's a concept that most shops need to understand. The supply web. Most people think production follows a straight line. It doesn't. It's a giant web. Raw materials, tooling, maintenance parts, outside services, heat treating, packaging, transportation, suppliers, vendors, inspection, shipping. Every piece is connected. And when one tiny component fails, everything behind it stops. That's why production often stops when something ridiculous, a sensor, a fitting, a bearing, a connector, a bolt, one tiny item, thousands of dollars of production, gone. The smartest shops map their supply web. They identify critical components. They identify single points of failure. They build backups because resilience matters. Want to know the biggest red flags? Here they are. Nobody knows where anything is. Nobody owns inventory. Nobody tracks downtime accuracy or accurately. Nobody understands critical suppliers. Nobody documents procedures. Nobody cross-trains employees. I can't tell you how many places I've seen all of these in one place. That's just asking for a disaster to happen. Those are organized warning signs, and they almost always show up before major problems. The good news, they're fixable. Every single one. So let's wrap this all up together. Biggest manufacturing problems usually aren't dramatic. They're hidden. They're the misunderstood print, the incorrect measurement, the poor GD&T interpretation, the untracked downtime, the slow changeover, the missing material, the aging machine, the forgotten supplier. They quietly drain profit year after year. The companies that win aren't necessarily the ones with the newest equipment. They're the ones that identify problems before they become disasters. They're the ones willing to ask difficult questions. They're the ones willing to improve. Because in manufacturing, the biggest threat usually isn't what you can see. It's what you stopped noticing. And that's exactly what we're here to fix. Welcome to Fixing Your Factory Flaws. Like, share, and subscribe. I will see you in the next one.